This video is on section 9.3 notes, matrix multiplication. So to multiply matrices, you must first match the dimensions. So if I write the dimensions of these two, I have a 2 by 3 matrix and a 3 by 2 matrix. And you have to look at the number of columns in the first matrix, which I'm going to call matrix A, and the number of rows in the second matrix, which I'm going to call matrix B, and those numbers have to match. So those have to be equivalent. The resulting matrix will have the dimensions equivalent to the number of rows from A and the number of columns from B. So the resulting matrix for this one would be a 2 by 2 matrix. As you go through your matrix multiplication calculations, you're going to multiply each row from column A, each row from matrix A is what I meant to say. So each row from matrix A by each column from matrix B. So you can see that there are 3 numbers here in A, which is why we've got a 3 in B, which is why we've got a 3. And so we're going to multiply those pairs of numbers together, and then we get the result, and we place that in the first row in the first column of the resulting matrix. All right, so if we wanted to kind of spell it out, we'd say that you'd do A11 times B11, A12 times B21, A13 times B31, and you add all of those together, and that becomes the first number in your resulting matrix. All right, so we're going to do several examples of this just to make sure that it makes sense. So if we look at these first 2 matrices, we see that A has the dimensions of a 1 by 2. B has the dimensions of a 2 by 1, and so first I match these two. I need to make sure that those are the same, and they are. So these match, and then the leftover dimensions give us our resulting matrix, and so this result is going to be a 1 by 1 matrix. It's going to be a matrix with just one number in it. So we go straight across this row and straight down this column as we multiply. And what I do is I use my 2 index fingers. I use my left index finger to go right and left, and I use my right index finger to go up and down in the second matrix. So for the first number, I'm going to have 2 times -3, which is -6. And then I'm going to go over with my left finger and down with my right finger. And then I have 3 times 4, which is 12. And this is a 1 by 1 matrix, so this is just one number here. And I can go ahead and combine those together to simplify. This matrix is just the number 6. All right, if we switch the order, if we do B times A instead of A times B, then we have a 2 by 1 matrix multiplied by a 1 by 2 matrix. We can see that the ones match. And so our resulting matrix is going to be a 2 by 2. So we just learned something important about matrices. We learned that matrices act different than regular numbers, which we could kind of tell, they're tables. But what we just learned is that multiplication is not commutative. And you might not remember what that word means, but commutative usually applies to multiplication. When we deal with multiplication of numbers, we think, oh, 3 times 5 is 15 and 5 times 3 is 15. The order doesn't matter, you still get the same answer. But what we are going to learn right now is that with matrix multiplication, that's not the case. When we multiply A times B, we get a 1 by 1 matrix. When we multiply B times A, we get a 2 by 2 matrix, and so they're definitely not going to be the same. So over here, I'm going to draw out my 2 by 2 matrix. And so my left finger goes left to right along the row. My right finger goes up and down along the column. But here we just have one number in a row and one number in a column. And so I'm just going to have one number times one number, and that's going to give me the resulting number that goes in that piece of the matrix. So -3 times 2 is the first number that goes in the first row, first column, and so that's -6. Then I'm going to move on to this space here, which is the first row, second column. So I'm staying in the first row with my left finger. My right finger is going to move to the second column. Negative 3 times positive 3 is negative 9. Now down here, I'm in the second row, but I'm in the first column. So I'm going to take my left finger and move to the second row. I'm going to take my right finger and move to the first column. 4 times 2 is 8. And then this space is in the second row, second column. So I'm going to keep my left finger in the second row. I'm going to move my right finger to the second column. 4 times 3 is 12. And so for each of those, I just had one number that I was multiplying to get those products. All right, so now that we've seen some basic examples, we're going to do one that's a little bit more difficult. So here we have C, which is a 2 by 2 matrix, D, which is also a 2 by 2 matrix. So I can see that these match, and I know that my resulting matrix is going to be a 2 by 2 matrix. And I'm going to leave some space here to show my work. And then I'll write my final answer over here. Okay, so I'm going to use some highlighters to show you exactly what I'm doing. I'm hoping that this will make your notes really easy to understand. So the first number in my final answer right here is in the position of the first row, first column. So what I'm going to do is I'm going to take the first row and I'm going to multiply it by the first column. So I'm going to take my left finger for the first row, my right finger for the first column. So I've got 2 added to 18. 2 plus 18. And so the first number is a 20. All right, now for this number right here, this is still in the first row, but now we're in the position of the second column. So I'm going to say stay in the first row, but now I highlighted the wrong thing. Oh no, stay in the first row. But now look at the second column. Pretend that I didn't highlight that. Okay, so first row with the second column. So we've got 4 and 24. 4 plus 24. Makes 28. Now this one down here, we are in the second row, but the first column. So I'm going to look at the second row, but the first column. So 10 and 42. 10 and 42 are what I'm adding together. And that gives me 52. Okay, and then the last number is in the second row, second column, and so I'm going to be looking at the second row and the second column. 20 and 56. 20 and 56. And so that gives me 76. All right, let's continue on to the next page. So here we have a couple more examples, but with some different dimensions. So we have E and F. E is a 3 by 2 matrix, F is a 2 by 3 matrix. So the 2 and the 2 match. Our result is going to be a 3 by 3 matrix. So for this one, we're just going to jump right into it. And I'm going to do the work in my head, or I can go ahead and add some numbers in my calculator off to the side. So remember, my left finger goes across the row, my right finger is going to go down the column. So in the first row, first column, I'm going to have 2 plus 18 is 20. First row, second column, 4 minus 9. First row, third column, -1, 6 is 5. Now I'm done with the first column, I'm moving to the second column, or I'm done with the first row, I'm moving to the second row, and I'm in the first column. So 10 and 42. Staying in the second row, but moving to the second column, 20, negative 21. Staying in the second row, but moving to the third column, negative 5 and 14 is 9. Now I'm moving on to the third row, and I'm going back to the first column, 16 and 12. Moving on to the second column, 32 minus 6. Third row, moving on to the third column, negative 8 plus 4. All right, and then this last one, we are again switching the order. So we're going to multiply F times E and see that when you switch the order that you're multiplying in, you're going to get a whole different matrix as an answer. So our resulting matrix is going to be a 2 by 2. And this time we're going to have 3 numbers that we're adding together for each of those positions. So I'm going to have to be really careful. So right here, I've got the first row, first column. So my left finger is going to go across the first row. My right finger is going to go down the first column. So 2 plus 20 minus 8. So 22 minus 8 is 14. Now I'm going to go to the second column, but stay in the first row. 6 plus 28 minus 2. Now I'm going to move on to the second row and go back to the first column. 6 minus 15 plus 16 is 7. And then I'm going to go back to the second row, but move to the second column. 18 minus 21 plus 4 is 1. All right. Next, we're going to look at some application problems. So this application problem says the first table shown below represents the number of economy, mid-size, and large cars rented by individuals and corporations at a rental agency in a single day. So this is the car size. These are the drivers, if they're individual drivers or corporations, that's who the contract is with, and just the number of rentals that they have. And then the second table shows the number of bonus points and free miles given in a promotional program for each of the 3 car types. So these are the car types based on their size. So again, we've got car size. And over here, these are the rewards. So bonus points, the number of bonus points that were given away that day for econo cars, mid-size cars, large cars, and then the number of free miles given away for each of those. It says write the 2 tables as matrices. In what order can you multiply them? And then what does the product mean? So I went ahead and I just laid out the tables in each order. So I'm just going to write this one first. We've got 3, 5, 2, 2, 6, 4. This is a 2 by 3 matrix. And then 20, 30, 40, 50, 100, 150. This is a 3 by 2 matrix. So in what order can you multiply them? Well, if I look at this, I can see that these dimensions match. I have 3 by 3. That matches. My result would be a 2 by 2 matrix. And whenever we do a problem that has a context, we just have to make sure that the units that are represented in each of these dimensions, that the units make sense as well. So right now the dimensions themselves are totally fine with multiplying these matrices, but I want to make sure that the units match. So here we had drivers by car size. So when I say 2 by 3, it was 2 drivers by 3 car sizes. And then over here, when I say 3 by 2, it was 3 car sizes by 2 types of rewards. And so now if I look not just at the number of the dimensions, but if I look at the units of the dimensions, I can see that the middle dimensions both represent car size, and they're even the same car sizes, and they're in the same order, which is important: econo, mid, large. And then the resulting matrix is going to be a 2 by 2, and it's going to be drivers compared to rewards. So we can multiply these matrices. We're going to get a 2 by 2, and I'm going to go ahead and do that multiplication. So left finger goes across the row, right finger goes down the column. So we're going to have 60, 60, 240. I don't want to do big numbers in my head, or mildly big numbers in my head. Okay, 360. Okay, the next one, we have 100, 60, 160, 320. Okay, then we've got, I'm sorry if that was confusing. I didn't do any of the other multiplication like that. So this time I happened to do first row and first column, and then second row and first column. So I kind of switched. So now I'm going to move over to the second column, and I'm going to do first row with the second column and then second row with the second column. So I'm sorry if that was confusing. I didn't mean to do that. So 150, 200, whatever that is. 150 plus 200 plus whatever 6 times 150 is. 1250. Okay, and then this last one is the second row, second column. So 250, 200, 600. $10.50. Okay, so yes, we can multiply them. The product is the drivers and the rewards that were earned by those drivers in that single day. So we have individuals, we have corporations, we have the bonus points that were earned by the individuals that day, the number of bonus points that were earned by corporations that day, and then we have the free miles that were earned by individuals that day, and the free miles that were earned by corporations that day. That's what our resulting matrix tells us. Okay, now if we switch the order of the two matrices, we just want to see, can we still multiply them? And when we do multiply them, what does it mean? So I'm going to write these matrices down: 20, 30, 40, 50, 10, 100, 150, 3, 5, 2, 2, 6, 4. So this is a 3 by 2 matrix. This is a 2 by 3 matrix. So if we check the dimensions on their own are fine. We have the 2's matching. Our resulting matrix would be a 3 by 3. So if we're not worried about the context, our dimensions tell us we can multiply these matrices. Now we need to look at the context of the problem, so we're going to add our units in there. We're going to use like what the matrices are representing. So here, the 3 by 2 is representing car size and rewards. Car size by rewards. And this other one is representing drivers by car size. Drivers and car size. So if we look at the two dimensions that matched up, that would be 2 types of rewards, 2 types of drivers, and those should match, and they don't. Those are different. And then when we were done multiplying, we would end up with dimensions 3 by 3 that represent car size by car size, and that would be weird. We wouldn't end up with a table that had any sort of meaning to us. So mathematically speaking, we could multiply the matrices, but as far as the context of the problem, it doesn't make sense. So the numbers match, but the units don't. And so we would not multiply the tables in this order. It would be a nonsense answer.